Hello, and welcome to CID Bioscience, CI-340 Photosynthesis System Training. The CI-340 is a portable handheld instrument capable of measuring net photosynthesis, transpiration, stomatal conductance, photosynthetically active radiation, or PAR light levels, and internal carbon dioxide in a convenient solid-state structure. For more information regarding other instruments offered at CID Bioscience, or support regarding your CI-340, feel free to visit our website or contact our support staff with any inquiries. The CI-340 ultralight portable photosynthesis system is an improved version of the first lightweight handheld photosynthesis system in the world. Featuring a new key design concept and compact solid-state structure, the entire system, including display, keypad, computer, data memory, CO2 and H2O gas analyzers, flow control system, and battery, are contained in a single handheld case. Capable of open or closed system measurements, the CI-340 has optional accessory components, like the soil respiration chamber seen here, as well as multiple leaf chamber options designed for specific commodities. Because the removable chambers are connected directly to the CO2 and H2O differential gas analyzers, there's virtually no time delay when measuring carbon dioxide or water concentrations. These features make the CI-340 the smallest photosynthesis system available for field and laboratory operations. Utilizing a low-power, non-dispersive infrared gas analyzer, the CI-340 can compare input and output carbon dioxide concentrations at a known flow rate to interpret photosynthesis rates. Infrared CO2 gas analysis can also be used to measure environmental responses and photosynthetic capacity, as well as determine other parameters like instantaneous gas flux measurements, gas exchange over time, photosynthesis to light response curves, photosynthesis to temperature response curves, and photosynthesis to carbon dioxide response curves. The term closed or open is used in the sense of whether or not the atmosphere of the leaf enclosing chamber is renewed during the measurement. In open systems, ambient air is used to replenish the leaf chamber. In a closed system, the intake and outtake are connected, recycling the CO2 gas inside the CI-340 during measurements. Aiding in these measurements are 9 interchangeable chambers for different types of leaves capable of being measured in an open or closed system. Larger leaf chambers are useful for both open and closed system measurements of all types of leaves. The chambers pictured in front with circular orange seals on the sides are useful for open system measurements for conifer needles or branches. Environmental control modules can be used to supplement the CI-340 in controlling light concentrations, temperature, and carbon dioxide and humidity concentrations. There are also accessories for chlorophyll fluorescence, useful for determining photosynthetic efficiency. There are 3 main modes for measuring gas concentrations in the CI-340: differential, absolute, and continuous mode, designated P, S, and C. Differential mode, or P, measures photosynthesis. This mode quantifies carbon dioxide and water concentration differences between the inlet and outlet gas flow. In differential photosynthesis mode, the concentration of carbon dioxide entering the leaf chamber, or CO2 in, is read for 20 seconds. Then a data point is recorded before the valve switches to the CO2 sensor. The concentration of carbon dioxide exiting the leaf chamber, or CO2 out, is read for another 20 seconds before the CO2 out data point is recorded. The fastest measurement time in this mode is 40 seconds. This is the most commonly used mode for taking measurements with the CI-340. Absolute mode, also known as single-channel absolute, designated as S, measures absolute carbon dioxide and water concentration from a single source, coming from the inlet. This mode is useful for verifying calibration gas or testing an environment for stability. This mode will not report net photosynthesis data. Continuous mode, which measures continuous photosynthesis, designated as C, measures gas concentration from the inlet once, then proceeds measuring from the outlet continuously. A new data point for CO2 out and net photosynthesis can be recorded as fast as every 20 seconds. This mode can only be used with standard gas, as the CO2 in concentration must be a known consistency during the entire measurement. The CI-340 is dependent upon a properly charged power source for efficient and reliable measurements and calculations. The included battery and battery eliminator is designed to provide the necessary power supply. The CI-340 system is designed to operate from 7.2 volt rechargeable lithium-ion batteries. When the battery is fully charged, it will last for approximately 5 hours of continuous use. To install the battery, align the contacts of the battery with that of the 340, seen in the video. Line up the battery so that it is about 7 millimeters offset from its final position within the battery mount. Press the battery toward the contacts and slide in the direction shown until firmly in place. To remove the battery, slide it in the opposite direction. When the battery voltage is below 5.6 volts, the message "Low battery" will appear on the screen. This indication signals an approximate 5 minutes of use remaining before the instrument shuts down. The battery eliminator can be used to power the CI-340 from the wall socket for long-term monitoring or for use when the batteries are not charged. The battery charger will only charge the battery or power the device. It will not do both at once. The CI-340 should only be used in low radio frequency ambient areas. Do not use near radio TV transmitting antennas or near electrical arc welders. When powering on the instrument, press and hold the power key for 2 to 5 seconds. You will see the words "Waking Up" displayed on screen. Allow at least 4 minutes for the unit to properly warm up before taking measurements, or up to 30 minutes for proper acclimation to the testing environment. Warm-up time will be longer if the CI-340 internal temperature is cold or if the CO2 analyzer has aged. There's a fail-safe that will not allow you to begin a measurement until the CI-340 is sufficiently warmed up. The keypad of the CI-340 consists of 19 keys. The arrows navigate through the menu structure, and the Shift key initiates the use of alpha character options available on the alphanumeric keys. A key should be pressed individually each time a command or letter is asked for. Pressing several times allows the user to enter the various shifted characters. For example, if the user wanted to spell out the word lot, L-O-T, they would press Shift, Shift, Shift 4 for the letter L, Shift, Shift, Shift 5 for the letter O, and Shift, Shift 7 for the letter T. The exit key aborts the operating function or stops a measurement. The Start Enter key enters a selected operation mode and enters data for an operation. Pressing Shift and the Start Enter key will start measurements without saving the data. Open system measurements are also called differential system measurements, while closed system measurements are known as depletion systems. Today, most systems are open. In this section, we will go over installing leaf chambers in preparation of open system measurements, setting up for a measurement, and reviewing the results. Always use the micron filter next to the intake with open system measurements. The micron filter helps protect from dirt or debris or moisture getting into the CI-340 and the erga. The 10 foot of Tygon tubing should be connected to the filter and the other end placed away from any possible CO2 source, such as the CI-340 operator, roads, or cars. There are several different leaf chambers available for use with the CI-340. They serve different sizes of varying plant elements. There are 9 available sizes of leaf chambers to conduct experiments for the open system method. One of them is seen here, the CI-301 LC5. The closed system environments deal with chambers of variable volume. There are 4 available sizes of leaf chambers to conduct experiments for the closed system method. One of them is seen here, the CI-301 LC7. It's recommended to choose a chamber large enough to contain the leaf environment. In other words, using a leaf larger than the chamber area will produce inaccurate results. The leaf should cover the entire area under the leaf chamber window. If it doesn't, a smaller leaf chamber should be selected for the measurement. The instrument may be kept on without a chamber attachment. However, don't start a measurement without first attaching a chamber following this checklist. Make sure that the O-rings are on the end tubes. Insert the end tubes into the CI-340 instrument. Align and tighten the end screws. And finally, connect the air and leaf temperature and PAR sensors. The air and leaf temperature sensors have two temperature sensors, an infrared sensor for leaf temperature and a gold thermistor for air temperature. The air and leaf temperature sensor and PAR sensors should be inserted into their respective locations on the chamber. Here we are using the LC3 leaf chamber as an example. Check that the air and leaf temperature sensor fits securely in place without bending any wires. The PAR sensor will slide into place within a slot located on the side of the chamber. Connect the air and leaf temperature sensor and PAR sensor plugs into their respective locations on the head end of the CI-340. Don't forget that the air and leaf temperature sensor are delicate and require a strong locking connection port. Take care when connecting and disconnecting the air and leaf temperature sensor to line up the red dots. Place the CI-340 in a stable location or hold securely by hand. There is a tripod mount on the underside of the CI-340 which can be utilized for hands-free operation. Ensure the sample fits adequately in the chamber. Place the sample in the leaf chamber, close the housing gently, and push the latch backward to lock the chamber. Allow the chamber environment to stabilize for 30 seconds before taking a measurement. Push the latch forward to open the chamber once measurements are complete, typically after 3 to 5 minutes in open differential photosynthesis measurements. From the Power On display screen, press the Start Enter key. The display will read File Name. Enter the desired file name and press the Start Enter key. If the file name ends with a number, the following files will auto-name incrementally by 1 in the default file system. Using a default file name will use all the same measurement setup parameters as the last measurement. Enter a time interval. This will represent the designated calculation time interval occurring both after the 20-second CO2 in and 20-second CO2 out stabilization times in differential photosynthesis mode. The data gathered across the designated time interval is averaged as output data for both the CO2 in and out. We suggest a time interval of 8 to 10 seconds, which will result in a 60-second sample time. A time interval of at least 1 second is required for net photosynthesis data. Enter P, S, or C for the measurement type, which represents the 3 different modes: P for measure photosynthesis, S for single channel absolute, and C for continuous photosynthesis. P is the most commonly used and already the default, so simply press the Start Enter key. The display will read Control CS, AD, or LA. This represents types of console control modules that can be utilized as accessory units to control the CI-340. If none are being used, then enter 0 and press the Start Enter key. The display will read Leaf Area in centimeters squared. Enter the area of the leaf sample, or the area of the window if the leaf takes up the entire chamber, and press Start. Each leaf chamber has the area printed on it. The CI-340 will remember the last leaf area entered as the default. The display will read Flow Rate in liters per minute. Enter the intended flow rate in liters per minute. Values range between 0.1 and 1 liter per minute, with a default of 0.3 liters per minute. When using the soil respiration chamber, or CI-301AD accessory module to control CO2 or H2O, the flow rate is increased to 0.5 liters per minute. The display will ask, Open or closed? This is asking if you will intake ambient CO2 for the open system, or if you will deplete the CO2 over time by recycling with the closed system style measurement. Press the Start Enter key for open system, or C for the closed system. If you enter C for closed system, you will be asked whether to end the measurement based on a CO2 concentration change or time in seconds. If you are unsure of what type of CO2 change to expect, enter a time end of around 60 seconds for initial tests. If the internal temperature of the CI-340 erga is detected to be warm enough to begin measurements, or once the unit is done warming up, the display will read Working and count down from 12 seconds to 0. The data will display on screen. Use the up-down arrow keys to view both displays of carbon dioxide and water data. To view your data graphically, switch to graphic mode from numerical data by pressing G or Shift 3. You will see the upper eighth of graph disappear when switching between modes. This is due to a memory limitation with the current software. This display is suitable for viewing large datasets graphically. Now that we've established proper methods for taking a measurement, we'll move on to working with files. In this section we'll go over software installation, finding and deleting files, file downloading, saving files on your computer, and viewing data on your computer. Measurement data is stored within the built-in memory of the CI-340. Once saved, the measurement results cannot be seen on the instrument, but rather transferred to PC via USB cable, utilizing the CI-340df.exe software program for Windows. For further information about downloading the CI-340df.exe program and transferring files to your computer, or other software downloads relating to the CI-340, visit the software download section of the CI-340 webpage at cid-inc.com. First, install the driver for the CI-340 on your PC. The driver utilized is a LIB USB driver for Windows. Next, install the CI-340df software to transfer data. Once the software is installed, connect the USB cable to the CI-340 and a computer. Power on the CI-340. Launch the CI-340df.exe on your computer. Click File, Open. Select Files to download and click Open. Multiple data files can be opened and saved at once for easy viewing within a single spreadsheet. After downloading completes, select File Save to save the data to the hard drive. Resave the file as a .csv or comma-separated values file. Then open the CSV file saved on the PC hard drive with a spreadsheet program, such as Microsoft Excel. The data will appear neatly separated into columns. View the files before permanently deleting them from the internal memory of the CI-340. Power down the instrument and disconnect from the computer when you're done. The CI-340 has a file system that allows a great range of data to be stored internally. It's been designed to emulate the familiar DOS applications of personal computers. Note that this menu will not be accessible when there are no files stored in memory. The message "No Files" on the top display line will be briefly displayed when this situation occurs. To use the File menu, or check if any files are stored, press the Enter key when Enter File menu is displayed. Press the up or down arrows to access the File menu when the instrument is first turned on. And to view all stored files, pressing the Exit key will exit this menu. Files are stored in chronological order. Up to 1,200 files or 2 megabytes of data are allowed for storage. The bottom of the display indicates how much memory is left on the CI-340 to record data. Press the Shift+2 key to represent the letter D, which deletes the last file saved, or to delete all files, press the Shift+9 key to represent the letter Y. The Shift and number keys will have to be pressed one last time to confirm the erase. Be aware that deleting a file removes it permanently from the internal memory, so be sure to transfer important data before deleting your files. The Delete All Files option is useful for clearing the memory after transferring or backing up all files. This table displays a key representing abbreviations the user will see when operating the CI-340. The direct measurements include data gathered directly from a sensor on the CI-340. The calculated measurements are based on the direct measurement results and the equations found on the CI-340 instruction manual. For measurements, take note that PN represents net photosynthesis rate, E represents transpiration rate, and C represents stomatal conductance rates, 3 commonly studied parameters. A printout of this key is adhered to the face of the CI-340 as a convenient visual reminder. This note is missing VPD, or vapor pressure deficit, another calculated measurement commonly used in greenhouses. Making sure the CI-340 CO2 IRGA is zero calibrated will ensure accurate results and is recommended before each use. To zero calibrate the CO2 sensor, fresh soda lime or 0 ppm CO2 gas, such as dry nitrogen gas, should be used. Soda lime is provided with the instrument for the CO2 zero calibration process. As always, allow the 0 ppm CO2 gas to run for at least 5 minutes before determining if zero calibration is necessary. A full span calibration utilizing a known CO2 gas standard in the range of 200 to 1000 ppm should take place every 6 months, depending on frequency of use. For gas flow regulation during span calibrations, connect the standard gas to the CI-340 and use a T-connection valve to help regulate pressure. Soda lime, which is a scrubber for carbon dioxide, can be used on closed loop for zero calibrating the CO2 sensor, seen here. Insert the loop-back green tubing with the 2 rubber O-rings into the valves where the leaf chamber normally attaches. The loop-back tube ensures there is no opportunity for leaks during the calibration. To zero the CO2 sensor as an example, power on the instrument and connect the green loop-back tube. Connect the soda lime tube or set the AD CO2 and H2O to 0. Use the up and down arrow on the main screen to navigate to Calibrate CO2. Press Enter. The instrument will begin warming up. You will see Start to set 0, else exit. Hit Start. You will then see Use 0 ppm CO2 gas. Press Start Enter. Setting 0 in 60 seconds will be displayed and the instrument will count down from 60 seconds to 0. At this point, the CO2 concentration of the gas passing the analyzer is taken as 0 ppm and the sensor is calibrated to read this level as 0. Therefore, if the gas isn't 0 ppm or hasn't been allowed enough time to run through and completely clear the system, the calibration can skew the instrument further. After the CO2 0 is set, the instrument will display Use Known CO2 Gas. Press Start Enter. If you wish to calibrate the CO2 span, hit Start Enter. If you only wish to zero the CO2 sensor, press Exit. If the sensor is due for its 6-month CO2 span calibration, connect a known concentration CO2 gas standard following the instructions provided by this diagram. Press Start. The unit will display concentration in ppm. Enter the known CO2 concentration ranging from 100 to 1000 ppm. Hit Start. The instrument will count down from 60 seconds and set the CO2 span. Press Start one final time to save the calibration. The display will return to the original Calibrate CO2 screen when you're finished. The water sensor should be zero calibrated weekly, or if not frequently used, monthly. Use a desiccant, like silica gel or 0% relative humidity gas, to zero calibrate. Silica gel is provided with the CI-340 to perform this calibration. Always allow the silica gel to run for at least 10 minutes before determining if zero calibration is necessary. Like the CO2 sensor, span calibration should take place every 6 months to maintain the accuracy of measurements. Upon purchase of the CI-340, a 1-year warranty is established and includes a 12-point maintenance and calibration of the unit. If the unit is no longer under warranty, please contact sales@cid/inc.com. We hope this training has been an informative introduction to your CI-340 photosynthesis system. On behalf of CID Bioscience, I'd like to thank you for investing your time and confidence into our products. If you have any additional questions about the training or areas not covered in the training, please contact support@cid-inc.com for further inquiries. Please feel free to share your research and feedback on the CI-340 as well. Our application science staff is ready to help you interpret your data. Have a good day.